Okay, hello everyone. My name is Petrović. I am assistant professor at the Faculty of Mechanical Engineering, University of Belgrade. My colleagues and I were dealing with structural integrity of a pipeline, including welded joint. You will see later what that implies. But firstly, we performed, sorry. Can you help me, please? Okay, thanks. We performed inverse methodology in order to obtain mechanical properties of all three regions of welded joint. As you all know, you have base material, you have weld metal, and you have heat affected zone, and they all have different mechanical properties. So in order to obtain their mechanical properties, tensile testing of specimen containing welded joint was performed. In the picture on your right, you can see stereo cameras. Loading was filmed using stereo cameras, and the results were analyzed using RAMI software, which is based on digital correlation method, digital image correlation. Digital image correlation implies it practically compares photos in undeformed and in deformed stage. And so displacements are measured and deformations are computed. So you can obtain the full deformation field, as you can see in figures on your right. Here you can see welded joint with defect. It doesn't have much with this that I will tell you later, because this inverse methodology is just a small part of overall ongoing study and ongoing project, which deals with welded joints and welded joints with defects, without defects, welded joints and corrosion. So this is just a small part of that. Here you can see a crack propagation filmed using system RAMIS, but to come back to our inverse methodology. In picture on your right, you can see a deformation field in a moment when plastic deformation occurs. And so we have the force and we have the deformation in that moment. And we use that to improve our numerical computational models. So we use those deformations and that force, we applied it on our numerical computational model. And we had some, at first, characteristics of the material are orientational. We did know characteristics of the base material of weld metal so-so, and we didn't know anything about heat affected zone. So we improved our numerical model. We changed those characteristics when deformations of the numerical model and deformations of our specimen, our experimental results were the same. We said that's it, and we got numerical properties, material properties of the three zones. So it was iterative approach, and we got those properties, and we decided to use that information to improve our computational model of a simple pipeline. As you can see here, pipeline is a good starting example because it is loaded with internal pressure, and the stresses are mostly membrane stresses. So the three numerical computational models are developed. The first one is the simplest one. It is the one without welded joints. All of us would model some construction in that way when we are planning to do some linear elastic computation or some linear elastic analysis. And the second and the third one included welded joints. But in the second one, heat affected zone have the same properties as the base material. And in the third one, all the properties obtained using inverse analysis were applied to that model. So those are properties that are obtained from inverse analysis and that were included in those calculations. As far as linear elastic analysis, the same. And that is one more confirmation for us to, when do linear elastic analysis, we can just model a pipeline without welded joints in a way that we all do practically. And why all the three models are the same? Looking in this diagram, you can see that all three materials have practically the same modulus of elasticity. So it is expected to behave in a linear elastic analysis for them to behave the same. But in nonlinear analysis, the situation is completely different. Here you can see a start of plastic deformation for the first computational model. And of course, it is more interesting to compare the second and the third with the first one and the second and the third one to another. And as you can see, the second, once again, the second has heat affected zone with the properties same as base material. And the third one, in the third one, all three zones have their own properties obtained using inverse analysis. And I think that the third model is something closest to the real behavior of a pipeline, including welded joints in nonlinear analysis in the plastic, when plastic deformation occurs. Internal pressure that caused plastic deformation is in the first column, and estimated stress concentration factor is in the last one. As you can see, stress concentration factor decreased when heat affected zone real properties are included into calculation. But that's not the only important thing. Stress gradient, as you can see from the table, stress gradient is completely different. And those are completely two different constructions. Practically, their probability of failure index is completely different. Their work life is completely different. So the significance of knowing real material properties of heat affected zone can be clearly seen from this analysis. And in the end, I would like to thank you all for your attention. And if you have some more questions, some further questions, you can send me an email or ask me now.